So last but not least, Catherine Satzke is going to talk to us about pneumococcal disease and vaccination or prevention. Thank you. Catherine is from the Modular.
Great. So thanks very much to the organisers for inviting me today to talk about pneumococcal vaccines in Australia and globally. But is it just the arrow there? It's not progressing. Oh, there we go. I just wanted to start by making a tribute to Professor Alan Cripps. Many of you are friends and colleagues of Alan, who passed away late last year. Alan made amazing contributions in the pneumococcal field, particularly around mucosal immunology, but also starting the Pneumonia Journal and co-chairing the ISPPD meeting with Amanda Leach. I think from my perspective, Alan was a amazingly intelligent person. I had the privilege of collaborating with him over the last couple of years. But I always remember his kindness, particularly for supporting early and mid-career researchers, and his amazing sense of humour as well. So before I get into the content of today's presentation, I want to declare my involvements, particularly with the companies involved in pneumococcal vaccines. So just to, I guess, provide some context, we're talking about pneumococcus, so the bacterium Streptococcus pneumoniae. It commonly is carried or colonizes the upper respiratory tract, particularly of young children and particularly in high burden settings. It's quite a dynamic and complicated organism. There's over 100 different capsular types, the immunologically distinct serotypes. And this capsule is also a key virulence factor for the organism. I guess in this context, particularly around vaccines, carriage is really important because we know that carriage underpins host-to-host spread, so transmission, therefore driving herd protection. And carriage is also considered a prerequisite for disease, including invasive pneumococcal diseases, pneumococcus detected in the CSF or blood, for example, as well as non-invasive infections like pneumonia or otitis media. Okay, so just broadly on pneumococcal vaccines, I guess they fall into two main types. So we have the polysaccharide vaccines, they're just the straight up purified sugars given to adults. And we also have the PCVs or the conjugate vaccines, where those sugars are joined to a carrier protein suitable for children and adults. And it's these PCVs that have had this really powerful herd protection by reducing acquisition in vaccinees of those vaccine serotypes. Then those usually young children are less likely to pass on to other members of the community. So I guess what I wanted to do in today's talk was, I guess, talk about some of the rapidly changing vaccine landscape as it applies to Australia, but particularly in the context of what's happening globally. And I guess given the time limits, that'll be quite a high sort of top level discussion. And the other thing I really wanted to do is, just, I guess, acknowledging this is the last talk of the day. We've had a whole lot of information, really to take a pause and to take a step back and think what kind of wraps around these vaccines. What are the really key questions that we need to understand globally, and what are the gaps? What do we need to do in the future? So in terms of what's happened across the vaccine situation in Australia, you can see there's been a number of changes, and they probably generally reflect the sorts of things that have happened globally as well. So in children, we started with the 7-valent vaccine, which is then expanded to the 13-valent, and also associated with changes in schedule. So we moved from a 3-dose in infancy to then that 3rd dose moving to a booster dose, so the 2+1 schedule. In adults, generally we're given the polysaccharide vaccine, so the 23-valent, but I guess in both schedules now sort of centred around the PCV13 with the 23-valent given to kind of high-risk populations in older children and adults. So, we're all here because we know that vaccines are very effective, and that's been the case in pneumococcal disease. We've seen big declines in the incidence of invasive pneumococcal disease in Australia. And you can see there was that kind of uptick in 2016, 2017, which led to the change in the schedule for paediatrics. And I think it'll take a couple of years to play out to know the effect of that, because you can see there's been that decline recently, but that's the effect of the COVID non-pharmaceutical interventions. I guess the decrease is particularly apparent in the young children, which you can sort of see there in the brownie colours. So this is a table summarising kind of what are the globally licensed PCVs in children. And I guess if we were talking, if I had a similar slide for adults, we'd add PCV 20 there from Pfizer. But for kids, the kind of current landscape is there's quite a lot of vaccines. After having a very stable kind of vaccine landscape, it's really changing a lot. So we have the 10-valent Synflorix and also the 10-valent from Pneumococcal, which is a low-cost vaccine, very attractive to low and middle-income countries, as well as the current Prevnar 13 from Pfizer and the 15-valent from Merck. So I guess this slide is to summarise the current state of play for approvals for the two vaccines that are kind of here right now, the 15-valent and the 20-valent. And you can see they're kind of following the traditional pathway of licensure in adults and then hopefully in children in key markets like the US and Europe, and also here in Australia. So I guess this is where we're at now, but I'm sure this slide will be out of date very quickly as the approval processes come into line. So I guess what I've got now is two quite busy slides, and it's not to, I don't want you to actually take the content away, but really to appreciate this is a summary of the paediatric clinical development pathway for the 15-valent and the 20-valent. And I think what I really want to do is use these to kind of illustrate some key concepts, and you can appreciate the similar pathways for the adult development as well. I think we could be critical. We could look at these and say, some of these studies are maybe in small populations, or in each site there's small numbers, perhaps not as much in special populations as we like, or in, where the disease burden is greatest. But actually, when I look at those clinical developments, I think they're very impressive. And actually, it's a bit scary, really, to think, PCVs have been around for decades, and how much kind of, I think rightly for safety reasons, but, how much time and effort and money gets put into these development programs for a technology that's been around for decades. But I guess notwithstanding the amount of effort that goes into these programs, there's some key questions that I think remain unanswered and really important for us to be thinking about. So one, I guess, that's been on people's mind in the global community is, what's the cost for each additional serotype? So can we keep just adding more and more vaccines into, more and more serotypes into these vaccines? So overall, you're going to get a diminished immune response to each particular serotype. So not to pick on PCV20, but I think you can sort of see the concept of that, which I think will be true for all, expanded valency vaccines, where you start to see reductions in either the concentrations of antibodies or the proportion of people that meet particular thresholds. So particularly post-primary series not meeting some non-inferiority thresholds, which then kind of get corrected after post-booster. So I think this will be true, as I said, for all high valency vaccines, but I think it's also true that we don't really understand whether that matters or not. How much protection is enough? What's clinically meaningful? And how does this vary by disease states? We have a bit more information on invasive pneumococcal disease because that's captured, but not much on pneumonia, which it can of course be caused by lots of different things besides the pneumococcus. How does it relate to carriage and the importance for herd protection? How does it differ by different epidemiological settings? We don't have much data for adults, so how does it vary by age? And of course, if you're in a setting where you've got a serotype that's causing a large proportion of disease, then it's going to be really important to include that in your vaccine, even if the antibody responses are a little bit lower. So I guess other people have been thinking about these sorts of things and wondering whether there might be some technological approaches to addressing these issues. So one, which I think hasn't got a lot of traction is, could we have sort of modular vaccines, maybe with a handful of serotypes that could be sort of brought in to knock down the major serotypes circulating. But of course, then you have to vaccinate more often, and the licensure pathways, I think, a bit complicated. Or could we have different sort of ways of constructing the vaccine that might allow broader protection? So just two I wanted to highlight today is PCV25 from Eventprise. This comes with quite a bit of support from the Gates Foundation. And I don't pretend to understand the technological detail, but my understanding is they use a novel linker technology to reduce the steric hindrance between the conjugate protein and the polysaccharide. And also I think it has PEG in there to increase the half-life of the polysaccharide conjugate as well. So based on technology used in Haemophilus vaccines, and I think also MenAfriVac. So this is a bit earlier in development, but a current age de-escalation study underway, I think in Canada at the moment. So they have, as I said, the kind of 25 valent, but also reading between the lines and the publicly available information, looks like a 30 or 32 valent vaccine under development as well. So the other one I just want to highlight was a 24 valent from Affinivax, now with GSK, which is kind of a similar approach to traditional conjugate vaccines, but instead of an unrelated protein, it's got pneumococcal proteins in there, as well as a kind of a slightly different way of presenting those antigens. So again, a bit earlier in development, and again with kind of a 24 valent one that's a bit more progressed and a 30-odd one that looks like it's coming through the pipeline as well. So that's just a snapshot of kind of a few of the key vaccines, but there's lots that I haven't talked about today, and lots in preclinical development as well. But I think the other things that kind of are really key to be thinking about these is, how on earth these vaccines are going to be implemented, how governments and agencies including in low and middle income countries which has huge burdens of disease, going to make these decisions. Can they give mixed schedules? Could you give I guess then you want to know which vaccine works best and when. Could you give reduced dose schedules, so fewer doses, and save a lot of money for these expensive vaccines? And there you want to know about individual protection, but also what the effect on carriage is, because that's what really drives herd protection. So just to very quickly give you a taste of some recent data from a big program of work, including a big clusterized randomized trial in Nha Trang, and two trials led by Kim Mulholland, who I work closely with, in Ho Chi Minh City. So I'm going to speak to the second trial there, where we were really focused in on the idea of reduced doses, comparing administration of PCV10 and 13 in 2,501 kids, as well as unvaccinated controls. So this is in an unvaccinated population. And I guess we think of reduced doses as something, obviously appealing to people in low and middle income countries where budgets are tight. But I think that's not exclusively the case, particularly given the UK's already moved to a 1+1 schedule in the last couple of years. And that was really on the basis of immunogenicity data from trials. And so we wanted to make sure in these Vietnam studies that we included that carriage data as well. So just one slide to, I think, give you the key results from that study, which should be out fairly soon. So you can see here we've compared PCV10 in blue and PCV13 in red, compared to children who were given no vaccine in black, and looked at PCV10 type carriage on the top row and PCV13 type carriage on the bottom row. And I think the main takeaway is reduced dose schedules look like they're quite effective. So they have a big reduction in vaccine type carriage. So likely to deliver individual protection, particularly in that second year of life, and to generate herd protection. There's maybe a little bit of a signal that PCV10 does a little bit better early and PCV13 does a little bit better later, which is kind of consistent with our earlier vaccine trial and some data from other groups as well. But I think that's an emerging area. So I guess all these things, as I said before, really feed into difficulties in either how we evaluate vaccines in the future for licensure, but particularly how countries are going to decide which vaccines to introduce, what schedules to introduce, particularly, and I guess, and how they're going to monitor the impact of these vaccines. So, you know, a lot of countries that we work with, the ministries of health have to provide these justifications to the ministries of finance to make sure these vaccines are maintained in the vaccination program. And like, I guess, everything that we've been thinking about over these last 2 days, really the key question, I think, at least for pneumococcal vaccines, we've had these vaccines for 2 decades now, but around half of the world's children remain unvaccinated. So I think what we should be looking ahead to is that kind of bigger goal about how we can get these effective vaccines to those that need it most, both within our own country in Australia, but around the world. Thank you.
I just wanted to see if you wanted to comment specifically on serotype 3 in the combination vaccines and some of the problems.
Yeah, so serotype 3 is a really interesting serotype. It's a, you know, big problem. So, you know, one of the most common serotypes when we look at disease incidence or prevalence. And it's also a very interesting serotype because, well, it has a very thick capsule, but it also can shed its capsule. So it kind of operates a bit differently to the other serotypes. So I think that makes it a pretty tricky serotype to tackle. Yeah, both in terms of kind of, I guess, being able to generate enough antibodies to actually be able to mitigate disease. So I'm not sure. And, you know, I think you actually have to provide the evidence then. It's nice to be able to have a vaccine that has high levels of antibodies, but how that translates into protection, I think you actually need to demonstrate that. Yeah.
We've got an online question for you too, Catherine. Do you estimate that with some serotypes not meeting non-inferiority in higher valency vaccines, that this will be clinically significant in terms of IPD and pneumococcal pneumonia?
I don't know. I mean, my feeling is that, you know, I think these vaccines are excellent vaccines and they probably are going to generate protection. So, but I think the immunogenicity is used for licensure, and I guess it's quite a crude measure because we know that the protection differs by serotype, so the level of antibodies that you need differs by serotype, but we use a kind of a crude measure applicable across all the serotypes. So, you know, I think they're excellent vaccines, but you have to generate the evidence of effect on disease and then also what the real world effectiveness is.
Catherine, do we underestimate, at least in adults, the benefit by not including the late effects, you know, the coronary artery disease and so on that can occur after pneumococcal disease in adults?
I don't think I could comment on that, Lou.
Is there anyone
Yeah.
who'd like to comment, or is it not significant? Certainly there's an emerging literature, I think.
Yeah. I guess my research is more on the childhood space, not as familiar with adults, but I think as a general concept, you do want to capture the whole breadth of the clinical spectrum.
Yep. Any other questions or comments for Catherine? In which case, thank you for a wonderful presentation.